Hello everyone. I'm welcome you all for the today's lecture video on abstract class. Abstraction is a process of hiding the implementation details and showing only functionality to the user. Another way it shows only essential things to the user and hides the internal details. Abstraction lets you focus on what the object does instead of how it does it. Abstraction can be achieved with either abstract classes or interfaces. The abstract keyword is a non access modifier used for classes and methods. Abstract class is a restricted class that cannot be used to create objects. To access it, it must be inherited from another class. Abstract method can only be used in an abstract class and it does not have a body. The body is provided by the subclass. A class which contains the abstract keyword in its declaration is known as abstract class. The abstract class in Java cannot be instantiated. We cannot create objects of abstract classes. To use an abstract class, you have to inherit it from another class, provide implementations to the abstract methods in it. Rules for abstract class. An abstract class must be declared with an abstract keyword. It can have abstract and non abstract methods. It cannot be instantiated, meaning you cannot create an object for the abstract class. It can have constructors and static methods also. It can have final methods which will force the subclass not to change the body of the method. Abstract method in Java. A method which is declared as abstract and does not have implementation is known as an abstract method. Rules for abstract methods. Abstract keyword is used to declare the method as abstract. You have to place the abstract keyword before the method name in the method declaration. An abstract method contains a method signature but no method body. If you inherit an abstract class, you have to provide implementations to all the abstract methods in it. So I'm having a class with a keyword abstract, which meaning it is an abstract class. Under that I'm having a method call me, which is an abstract method, and then I'm not having code block of code for the abstract method. Now I'm having another function call me too, and at that I'm printing this is a concrete method. Now I'm actually creating a subclass B, inheriting the abstract class methods and members. In class B, I have a function call me, which will print B's implementation of call me. This is the class abstract demo, which has the main function. I'm creating B object for the class B, and I'm accessing, I'm actually invoking the function call me and call me too using the object B. So this is how you have to create. Yes, we cannot directly create an we cannot directly what we cannot give the code of block directly to a abstract method, and the abstract method can be used in the abstract, it can be created in an abstract class. The abstract class cannot be instantiated, meaning we cannot access it using an object. If we want to do so, we can do by creating a subclass to it and extending the properties from class A, and thereby we have to create an object for class B and we need to invoke the functions and access the members. Another program for the understanding abstract classes is given. Look, this program. It has a class which is abstract class figure. Under that, I'm having two variables dim1 and dim2. It has a function figure with two input arguments a and b, which will assign the values to dim1 and dim2. An abstract double area. Abstract double area, actually this is a function which is abstract. Abstract function is not, should not have it will not have the code of block. If we want to then include the code of block, it can be done using a subclass, extending it. So class rectangle is extending the figure class, which actually inherits the properties of the class figure, and also we can access the functions and we can add the code of block for the abstract functions by the subclass, creating objects for the subclass. Here I'm having a rectangle function, and then the double area, which is actually having the now double area here, it is abstract, but here it is having the code of block inside area of rectangle written dim1 into dim2. So I'm having a class triangle here which extends figure. This figure is the parent class for rectangle and triangle, but here I'm having rectangle method, here triangle method, and here I'm using the abstract method which is here. I'm including this code. I'm including area of triangle, and I'm writing area of triangle formula here. So this is how we can access the variables of an abstract class using the subclass objects, and then I can able to add the block of code for the abstract method in the abstract class. Class abstract areas is having a main function. So continuation of this program, here we have class triangle, class rectangle, and abstract class figure. This is the main function which the execution of the program starts, from which the our execution starts. And here I'm having rectangle R is equal to new rectangle, which is the object created for the rectangle class, and T is the object for triangle class. And I'm now area is the method for the rectangle class or object is created, which will invoke the area in rectangle. Yes, rectangle. And for triangle, I am creating an object which will invoke the area method here. But I'm actually initially I'm creating these method as abstract, which can only be invoked through the subclasses. I hope you enjoyed the video, and let me meet you in the next video lecture. Thank you all.